Not everybody knows that PagerDuty is much more than just the pager. We have much more features like the SRE agent that João presented this morning. And because we have a lot of data that can be used for our AI agents that we have from our customers, we can use that data to make the life of our customers much easier, like providing information about related incidents, related past incidents, pull run books information directly from Confluence or GitHub. That are the main capabilities of our SRE agent. We have more agents inside PagerDuty. This is another one, which is Insights agent. It's basically an analytics agent that can get analytics from the incidents for the teams. Here we have a simple example from our colleague Antonio. He's asking how many major incidents that we have in the last 90 days, and the agent is just pulling out the metric for that. I'm not going to enter in details in these agents because the presentation is not about that. And we also have more agents in the PagerDuty, but as I said, I not talk about the agents for today. So why do we care about agent observability? This is a famous case of Air Canada that the GenAI system actually issue a refund for one of the clients, and actually it was an hallucination. It shouldn't issue a refund for that client. So it was a mistake. It was an exception to the refund policy. And in the end, they had to give the refund to the client because the agent was speaking for the company. So AI failures, they can create production incidents and they can create legal and financial risks. They can impact customers and revenue inside a company. So we believe that they deserve the same observability and the incident response as we would give to any other service inside a company. Here we have another example. In this case, is a lawyer that used ChatGPT to see a lot of precedents. But the problem is that none of these precedents actually exist. So it was very embarrassing for the lawyer. And I am sure that had some repercussions for the lawyer and for its clients. And another case, this one was pointed in Twitter, actually. This is a Google AI saying that to get your cheese more sticker in your pizza, you can actually add glue to it. So this is exactly why we need observability and guardrails and monitoring for AI agents, because we need to verify the output, we need to verify the source, because like in this case, like a simple joke, the source for this was probably like a Reddit joke, but we can see that a simple joke caused a really possible harmful guidance from the Gen AI system. So to handle that, we have two types of evaluations in place. Offline evaluation, where we evaluate the agent as we are developing it, so that if you make change to the agent, if it's impact on the quality of the agent, in the performance of the agent. And we also have online evaluations. The online evaluations, they are basically to evaluate the agent as it is interacting with real users in production. So we are basically evaluating the traces of the interactions with the real users. So I'm going to, about offline evaluations, we have basically, we are assessing correctness and response latency. And for an for online evaluation, we are assessing much more metrics because this is basically the main observability that we have for agents in production these days. And we are also we also have monitors and generate incidents in case we see much of these errors. So we are evaluating relevance, groundedness, tool usage, response latency, internal API errors, and human feedback and user sentiment. So I am going to start talking about correctness, which is the offline evaluation. So basically, we have a job that runs the evaluation in a schedule, or it can also be run manually. We have this in our deployment pipelines, so the developer can make change to the agent and can evaluate to see if those changes are causing any problem to the agent or if it is impacting performance or quality of the response. And in these jobs, they also run like in a schedule daily or weekly, depending on the agent. So first of all, we need to select some input question to give to the agent. We try to make this input question as close to the real questions that we see in production from our customers. And we get the response back from the agent. After that, we have one endpoint. Actually, it's not really an endpoint, but we have a ground truth source that is basically to get the expected answer for that question. So we retrieve that ground truth, which is the expected answer, and we keep that as well. And then after that, we use LLM as a judge to compare the response from the agent with the expected answer, and then we can evaluate if the answer that was provided by the agent was correct or not. And after that, we just upload our metrics to our monitoring platform. That in this case, we are basically using Arise. So these are the main ingredients that we need for offline tests. We need to define the input questions, which is the most important part of this workflow. They need to be close to the interactions that we see in production. It needs to cover edge cases as well. So here we just have an example that would fit in Insights agent. And about the ground truth logic, this could be an API call or ISQL query, anything that can provide the source of truth for that question. And then the last and most simple is basically a prompt that we send to LLM to assess if that answer is correct or not. So lessons learned. First, implement these tests. It's a lot of work because to make it comprehensive, it should represent the real interactions that we have in production. It takes time, and also it takes time to develop the logic to retrieve the ground truth. But it's worth, like we can see that it pays off really quickly because we can see that after we start implementing these regression tests, these offline tests, we can see that give a lot of visibility about where the agent was making mistakes. And the developers, they start to improve the agent on that direction and also prevent us to create any regression in new versions. Because before that, the developer, he was basically testing it manually with a few questions and checking if the agent was answering correct. But he was missing a lot of edge cases and other scenarios that he could be like making the quality even worse, even though he was fixing another problem. And this is not something that we implement once and forget. Every time that we see an edge case in production, we try to circle back and implement that regression test, that offline test. So we make sure that in the next versions of the agent, we will never make that mistake again. And about online test.
Yeah, now it's going to be me. Very strange to hear myself while I'm talking. But yeah, so the idea of the online test is we had already, as Murilo described, a way to basically on every deployment, we could just say, is this agent performing better or not? But then what about when it goes to production? Because in production, we don't have any ground truth reference, so we cannot compare with anything. So we had to have a way to still evaluate the agents, or at least have a way to monitor the quality over time. So here, what we have, it's the starting point of all of these. We have our, as Murilo said as well, Arise, which is the platform for monitoring the agents. So basically, initially, we have these agent traces that basically says what was the logic or the flow of the agent within each of the calls. So you see the input and the output, but you also can inspect what the tools, like which tools were called and what were the parameters and all of that. So we started with this and we thought, okay, we have all this information, what can we do to still assess if the agent is getting it right or not? So we then went to basically this idea. So we have these resources, we have the user question, the agent answer, and the tools output. And there's these kind of easy to understand concepts that connect these kind of resources. So the relevance, it's a way to evaluate, is the agent actually answered the user question correctly? So all that information is there because we know the answer, we know the question, we can just maybe ask an LLM, just another LLM as a judge, to basically judge this. Another one is groundedness. It's also, I think, the most important one actually, which is the agent making up stuff? Is it making up facts when giving an answer to the user? So we know what the tools output are, and we can just inspect, given again a prompt for the LLM as a judge to basically say, is it like, is the agent saying all the information correctly, or is it making up numbers? Actually, an interesting case that is not here, but we already were able to get an hallucination in production because of this. So this actually works. It's a good way to assess. A third option is to also inspect basically how the agent decided about the tools, which is we have all the tools descriptions that the agent can use, and we know which tools it called. So given the user question, we know, or we can ask, is it a good way to answer this question? So the tools that the agent use, do they make sense? And we also use an LLM as a judge for that. So the step is a bit simpler than the regression test because here we don't need to call any agent. So the agents were already called. It was already running in production. We have everything that we want in our monitoring platform. So we can just get all the agent traces into a job that then calls using all these three LLM as a judge, calls the LLM endpoint, and then we get a label plus an explanation. So it's not only assessing if it's grounded, hallucinating, or if it's relevant or not. We also need to have a rationale behind it. So all these LLM as a judge can also provide an explanation. It's also a way to debug the LLM as a judge, which kind of, you can see already that there's a second order problem already being created here. I'll give you more about that in a few slides, but for now, let's say that the LLM as a judge is just perfect. But then the goal is to loop these and basically log these evaluation results back into this monitoring platform, which allows us then to completely close the loop and send these like evaluation metrics is still inside the monitoring platform. We can then configure some triggers, like if the groundedness is too low for this agent, we can just have some services in PagerDuty being alerted and having maybe some on-call team that is building the agent being alerted because of this, which is nice. And by the way, we also use PagerDuty inside PagerDuty to monitor our own incidents. So our own agents are being monitored fully using this loop, which is nice. Okay, so here about the resources that we need for each of the three judges. It's just to give you basically an overview on what we need to have on each of them. So not all of the judges need to know about all the information, but this just gives you a picture on how it works and how it's organized. Okay, so I mentioned that LLM as a judge is it's another LLM, another problem to fix. The most of the cases, this is not like the rationale. Usually it's good and it gets you to correct answers. The problem is if you, and was an experiment that we did, we just took the same agent response for a data set, like for all these different questions in the data set. We just passed this 20 times to the LLM as a judge, and we saw how the answers actually would fluctuate. So they are not always constant. So this is a problem. Since it's non-deterministic, you might have a variability in the relevance and the groundedness at least. And you can see also let's forget a bit about the original and new judge, but between Cloud 3.7 and Cloud 4, you can see that Cloud 4 has less variability, which is interesting also because maybe you could just try to improve the whole LLM as a judge thing, maybe changing the prompt. But if the model is just better and has less variability, maybe you can just use that. So you can see it's not a huge impact. It's just something that you need to be aware because it fluctuates about 5 percentage points or something. Okay. So finally, we also wanted to assess, because we have these regression tests with correctness, and those are grounded into a ground truth answer, and these are not. And we wanted to evaluate, are these still getting like any signal from, is the agent actually making incorrect statements? So we use the same golden data set that we have for the regression tests. We run these through the correctness. So we had this already. And now we run also for the 3 judges for groundedness, relevance, and tool selection. And we were trying to see if any of them says that it's hallucinating, or the tool selection is not correct, or it's not relevant. If any of these 3 judges say anything wrong, is it also incorrect? So we wanted to basically measure how good it is. And we could achieve 70% of recall, which means that from all the incorrect answers we get, we flag 70% of them using this. And in terms of precision, so every time we have any of these LLM as a judge saying something wrong, 50% of them is actually a problem. So it's something good that if you have this in production, you can pay attention to these alerts, because 50% of them actually mean something. Okay, so I think that's it. Yeah. Thank you.
Test. Okay, it's working. So we have time for questions. Who wants to ask a question? There we go.
Thank you for the presentation. I think I didn't quite understand how you're verifying groundedness in the online tests. The offline is easy, like you have some sort of synthetic question and the answer to that question, or getting the answer from somewhere. But how do you do this with online tests? I didn't quite understand this.
We are not actually.
Okay.
Oh, groundedness. You mean groundedness, not correctness, right? Groundedness. We are basically checking if all the information that was provided in the answer, if they were retrieved by tools. So if we have any number or any information that isn't the agent's answer, but it wasn't provided by a tool, then it is hallucination.
Okay, yeah, that makes sense. Thank you.
Any more questions? There you go.
Thanks for the presentation. You didn't share that, but like, what happens when you detect some of these hallucinations? What kind of, you have different bots for different agents for different behavior, right? But what is your incident response to a team got paged on that specific agent? I'm interested to know how that works, if possible.
Yeah, it's a good question, because as of now, it's a work in progress, actually. So we want to set the standard, of course, and in most of the cases, this is how we built our golden data sets as well. Okay, something was wrong with this question. Let's just use that to include in the golden data set, so that on other PRs, you can actually fix that. But the process itself, it's not yet fully defined. But it would be something around that. Maybe on that day, you could just try to fix it right away if it's a very big problem, if something is really wrong. But usually it shouldn't be something on the agent logic itself. But I guess someone that with the knowledge of AI enough that could maybe tweak the prompt but it's a bit not very clear to us as well.
We have a monitor, so if the monitor is below the threshold, it would keep paging you. So you need to go there and fix.
More is interested on the fact that, so if I'm in an incident call and I'm using the agent and it's hallucinating next to my buddy that is also hallucinating, it's not a good behavior next. So I'm more interested in this workflow of like, how do you warn also the end user? And in this case, maybe it's still you because you're using it internally to build it up. That was my curiosity, because it's an interesting challenge.
Yeah. Yeah, we don't have a process for that, but yeah, we hope the teams, they pick up the incident and just start to create tests to prevent that for the future or to improve the agent.
Okay. So we have time for one more. Once. Going twice. Okay, everyone. So give it up for them. Thank you so much. Give it.